Welcome to lesson 4 of 4 in this tutorial, covering bond enthalpies. This is the final lesson in the series of 4 videos covering the topic energetics. In the last lesson, we learnt about Hess's law and how to perform some calculations. Here are some key learning objectives for this session. First, we want to understand bond enthalpy. And then we will look at calculations involving mean bond enthalpies. Here are the AQA specification points for this tutorial. Pause the video now to have a read through them before we begin. The first objective is to define the term mean bond enthalpy. We will be covering 2 definitions in this section of the video. The first is to look at the term bond, and the next is to look at mean bond. The bond enthalpy is the energy required to break 1 mole of bonds. As energy is required to break bonds, the value of bond enthalpy is always positive. And the reaction to break a bond is always going to be endothermic. The value of the bond enthalpy is also equal to the energy required to form 1 mole of bonds. The mean bond enthalpy is the average bond enthalpy of the bond. It is derived from the full range of molecules that contain this specific bond. It is the average amount of energy that is needed to break a bond, which is averaged over a range of different compounds. The mean bond enthalpy takes into account the type of environment that the bond is found in, as this affects the amount of energy that is required to break it. Let's look at some mean bond enthalpies in different compounds. First, we will look at methane. Then, we will look at chloroform. If we consider the compound methane, CH4, it has 4 CH bonds. Breaking each of these bonds takes a different amount of energy. This is why we use a mean bond enthalpy for the CH bond. The same CH bond in a different molecule like chloroform, shown here, will have a different bond enthalpy. This is another reason why we use mean bond enthalpies, which is a bond enthalpy averaged over a range of molecules. Now let's move on to our next learning objective, covering the calculations of mean bond enthalpies. You should be able to use mean bond enthalpies to calculate an approximate value for delta H of reactions that occur in the gaseous phase. Earlier, we learned that the enthalpy change is the combination of formation and breaking of bonds. The enthalpy change will be positive if more energy is required to break bonds than the amount of energy released when bonds are formed. The enthalpy change will be negative if more energy is released for formation than the energy required for bond breaking. We can use the following equation to calculate an approximate value of delta H from mean bond enthalpies. It is defined as the heat energy transformed in a particular reaction at a constant pressure. The equation is shown here. It is the energy required to break the bonds minus the energy released when bonds form. Here is the short version that is acceptable to use in AQA exams, as long as you know what it stands for. Here are the units for this reaction. Here's a method to calculate mean bond enthalpies. First, we write out the displayed formula. Then, we work out the bonds broken and formed. And finally, we can calculate the enthalpy change of the reaction. Let's try a practice question before we finish the video. Pause the video now to attempt this on your own. This is the answer to the question. Let's go through it step by step. First, we need to write out a displayed formula. In this instance, we would have C double bond C with 4 H's plus H2 going to C with 6 H's. This is the visual representation of this reaction here. Next, we can write down the types and numbers of bonds that are broken and formed. So our broken bonds are going to be 1 C double bond C, which is 1 times 614, and 1 H bond, which is 1 times 436. These values are found here. The bonds that are formed are going to be 1 C bond and 2 CH bonds. These values again are shown in the table. Finally, we can use our equation to calculate the enthalpy change of the reaction. So in this instance, it will be the energy to break the bonds minus the energy released when the bonds form. So here we can simply put in the numbers. So this will be this minus 1174, leaving us with an answer of minus 124 kilojoules per mole. Again, you might have to use the data book to find the bond enthalpies you need to answer the question. You should become familiar with using the AQA data book when doing your past papers. This will save you a lot of time in the real exam. Be careful when you use the data book in the exams though. It's easy to make mistakes when copying the values onto your exam paper. Let's move on to our final specification point for this section. We're going to look at some limitations of using mean bond enthalpies. First, we need to understand that the delta H of a reaction calculated using mean bond enthalpies is only going to be an approximate value. It is different to the value you get when you use Hess's law. The bond enthalpy is just a mean in the reaction that you are concerned with. The specific bond that is being broken might have a different bond enthalpy to the mean bond enthalpy that was used. Secondly, the reactants may not be in the gaseous state. The mean bond enthalpies only apply when the reactants are in the gaseous state. Finally, the mean bond enthalpy used itself is an average value, not an exact value. This means that your final answer will also be an approximate value rather than an average one. We've now covered all the specification points for this tutorial. Feel free to skip back through the video and re-watch anything that you might be unsure about. We have now completed Lesson 4.